Greetings and welcome, friends. Mr. Waddy here. We are going over yesterday's homework, section 5.5, solving equations by graphing. These problems are found on page 265-ish. Some of them are probably on the next page. But here we go. It says, use the graph to solve the equation. Check your solution. So for question 5 here, the way these problems worked was we took each half of the equation and wrote it as its own equation with a y attached to it. So an input-output, the equation of a line, y equals mx plus b, sort of thing like that. You didn't have to necessarily write these down, but I just kind of want to show where those came from. Right, so what I would have done was set each side equal to y, and then I would have graphed them. So notice this first line had a graph, a y-intercept at -1 and a slope of down 1 over 1. There's the purple line. The blue line had a y-intercept of 3 and a slope of 1/3, so up 1 over 3, or you could do down 1 backwards 3. And we see that the intersection of these lines is right here. That appears to be the point -3 up to -3, 2. And the solution that I want is specifically just the x-coordinate of that intersection. So that is the solution of that system. So let's just do a quick check. Why not, shall we? I guess I'll use green. All right, so check. I'll plug it in the original problem. So the opposite of -3 minus 1 is that equal to 1/3 times -3 in parentheses plus 3. So the opposite of -3 is +3. A third of -3 is -1. And 3 minus 1 is 2. And -1 plus 3 is 2. It checks out. I like it. I like it. All right, so that was one where the graph was done for us. I like when they kind of piecemeal have us work our way through these problems. Here's one a little bit trickier. So here we go. Let's write our two equations. We've got to do all the work ourselves in this case. So y equals 1/2 x minus 2 is the first equation. The other one, I'm going to flip this around. I'm going to write this as y equals -5x plus 9. So if I put the y equals mx plus b, right, I'm just putting the x and the slope first is the idea. And as far as graphing these, the slope of this one would be 1/2. The slope of this one would be the -5. And the intercepts, b would be a -2. And over here, b would be +9. Sorry, positive 9. All right, so let's graph both of those. I'm assuming I gave myself enough space. So let's see. First one, y-intercept is at -2. A slope of 1/2, so up 1 and over 2. Up 1 and over 2, right? And I just move by my slope. Watch me move by my slope. There we go. And draw that line. Here we are. Oh, I think that fell off that point there. That's pretty close. So there's our first line right there. And let's graph the blue line. So I start at the y-intercept, +9, which for my graph, by the way, this is 11 grid units high, so the 10 is actually this one right here. So let's see, there's the 9, and the slope is -5, so down 5, 1, 2, 3, 4, 5, and over 1, and down 5 again, 1, 2, 3, 4, 5, and over 1. Oh, I think I sunk your battleship, friends. I found the intersection. And let's see, let's draw that line. And so the intersection between these lines, bless you, right, is going to help us in solving this equation, right, where variables were on both sides. And this intersection occurs at 2, -1, and the solution is just the x equals 2. X equals 2. All right, now it's much easier for linear equations anyway, like this, to have just solved this algebraically. But this method does work for more complicated problems as well. We'll do the quick check again. I'll do the check in orange this time. Check. 1/2 of 2 minus 2, no parentheses there, equals 9 minus 5 times 2. Half of 2 is 1. 9 minus 10. Okay, 1 minus 2 is negative 1, and 9 minus 10 is negative 1. And it checks out. That's good news. So that is, in fact, the solution. And like I said, we only are interested in the x-coordinate of their intersection. So we're kind of turning this into a graphing problem when it didn't need to be. But it's helpful in the case like this sometimes. I actually think the book chose a tougher route the way they did this. They first dealt breaking this into two cases. So they said 2x is equal to x plus 3, all right, is one case. And the other case is 2x equals the opposite of x plus 3. All right, so they're saying either, for these absolute values, either both of them were the same sign, or maybe one of them was negative. And those are the two cases. And now we end up graphing like a whole bunch of lines. Oh, wrong color. I start with purple, don't I? Yeah. So I'd have y equals 2x is one of my lines. Okay. Another one will be y equals x plus 3. And your book graphed these on two separate coordinate planes, but we realized that y equals 2x would have shown up twice. So I don't need to hit that one again. Let's see. Let's hit, I'll do naranja. Oh, let's actually distribute that first. So this would be 2x equals the opposite of x minus 3. There we go. And yeah, so I'll have y equals negative x or minus 1x minus 3. So let's graph these lines. I'm assuming you guys are good with slope and everything. So this one, y-intercept is 0, and the slope is 2, right? You could have thought of this as having plus 0 there if that helps you. So start at the 0 on the y-axis, and then up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. And let's draw our line. And there we go. Hooray! And let's see, this blue line has a y-intercept of 3, so I'll start up at 3 here. And a slope of 1. So I'll go up 1 over 1, up 1 over 1, up 1 over 1. Found an intersection there already. Like so. So I guess, yeah, I'll read the intersection here for these ones already. This one happens to be the point, looks like 3 comma something, 6. So x equals 3 is the solution that comes from this side. And let's graph this orange line. See what happens there. So y-intercept at negative 3, down 3. And a slope of negative 1, down 1 over 1. Right, down 1 over 1, down 1 over 1. So let's plot this. And what I'm looking for is the intersection that this orange line will have with the purple line. The purple line was the one that was common with both of them. Right. Yeah, the purple line right here. So, if I want to find the intersection, looks like it hits right there. And that point looks like negative 1 comma 2. And so x equals negative 1 would be our other solution. Let's just do a quick check. They asked us to. I guess I've been, yeah, I'm doing okay on time. I guess I'll do green. Let's check this 3 first. So is the absolute value of 2 times 3 the same as the absolute value of 3 plus 3? And let's see. So that's absolute value of 6 equals absolute value of 6. Yeah, 6 equals 6. Yeah, that one checks out. Let's try this negative 1. Is the absolute value of 2 times negative 1 the same as the absolute value of negative 1 plus 3? 2 times negative 1 is negative 2. Won't stay that way for long. Negative 1 plus 3 is 2. Oop. Nope. Man, there we go. And the absolute value of negative 2 is 2. The absolute value of positive 2 is 2. It worked out. So both of these solutions worked. Now, what I thought was more interesting, alternate world reality, here we go. Let's see, what's a good color I could work in? Let's say I took this to begin with, abs 2x equals abs x plus 3. Question? Did I make a mistake? Comment? Oh, good save. Yeah, -2. Yeah, my error didn't expose itself because I only ended up needing the x. But yeah, good save. That is a -2. So another way you could do this is if you said y equals absolute value of 2x and y equals absolute value of x plus 3. And we actually know how to graph those types of graphs. So this one would end up being a horizontal shrink by a factor of 2. And this one would have been a horizontal shift left 3 units. Let me graph those quickly in Desmos for you. You don't have to do it this way. You won't be graded on doing it that way. But let me just graph those real quick. Y equals abs 2x. All right, so here's y equals abs 2x. Notice I literally write ABS. And let's see, y equals abs x plus 3 all inside. Y equals abs x plus 3 all inside. There we go. And so if I wanted to find the intersection between these two, oh man, get out of here. Get out of here, you thing. Let's see, I've got all sorts of colors and glitching flying everywhere. Yeah, so here's the graph of those. And I believe, yeah, so here's -1, 2. And here is 3, 6. And notice that x equals -1 and x equals 3 were the same solutions that I had earlier, right? Yeah, so you actually could have graphed those both in their absolute value form. Notice the blue graph is a vertical stretch by a factor of 2, and the orange graph was just shifted to the left 3 units is the idea. I think that's all I did for the, yeah, that was the last problem. So thanks for watching, internet friends. Have a great day.